All right, guys. Hey, if you haven't figured it out, Mr. Bedell and I are trading off. We kind of got a little behind on making videos, and so we're trading off times here to be able to get these done for you guys in time. So we're on section 3, chapter 10, and yesterday we talked about difference between minor arcs and major arcs, and so you need to have caught that to be able to move into this next section. So here's a theorem: two minor arcs, so less than 180 degrees, are congruent. The measure of the arcs themselves are congruent if and only if their chords are congruent. So remember that if and only if goes both ways. If the arcs are congruent, then the chords are congruent. If the chords are congruent, then the arcs are congruent. Okay? And so as we look at this diagram that we have here, we can see that those two chords, AB and BC, are congruent to each other. So let's see what they've got for us here. It says if measure of arc AC, so the outside arc there, equals 150 degrees, find the measure of arc AB. Well, if you look at that circle, we would need to take the 360 degrees that make up the circle and subtract out the 150 that AC is. And that would give us from A to B to C, the major arc that way. Okay? So if we do that subtraction, we would get 210 degrees, 360 minus 150. And then because those two chords are congruent, those two arcs are congruent. And so they're equal to each other. And so we would just split that 210 in half for each one of them. And so they're asking us for AB. So the measure of AB would be 105 degrees. So you take the full circle, 360, minus the AC arc that they gave us of 150. That gives us 210. We divide it in half because we know arc AB and arc BC are congruent to each other. That gives us 105 degrees for arc AB and arc BC. Okay. How about this one? Basically the same question here. We have arc AD given to us as 128 degrees, and they want us to find arc AB. And notice that chord AB is 34 units, and chord BD is 34 units. And so the red arc AB and the black arc BD have to be congruent to each other. So we would take the 360, subtract the 128, so what does that give us? It would give us 232, and we would take that 232 and then divide it in half because the two arcs are congruent to each other again. So that would make arc AB equal 116 degrees. Excuse me, half of the 232 that we got. Okay, so those two problems are basically the exact same type of problem. So make sure you understand those. Okay, we have two other theorems here. Pretty critical theorems, so make sure that you understand the difference between them. The first theorem says if one chord is a perpendicular bisector of another chord. So looking at this diagram down below, it would mean that AG is perpendicular to, because it shows the right angle there, perpendicular to, and it's bisecting BD. Okay, so if that's the case, then it must be a diameter. It's the only way that you can perpendicular bisect a chord is only if it's a diameter. Okay. The second theorem says if a diameter is perpendicular to a chord, then it must bisect the chord and bisect its corresponding arc. So they kind of go hand in hand, these two theorems. Okay, they kind of, one goes one way, one goes the other way. And so they kind of go together. So if we have a diameter that is a perpendicular bisector to a chord, then it bisects it and its arc. Okay. So based on those two theorems and this diagram right here, let's see if we can answer the following questions here. So they want us to find the length of segment BF. Well, BF is half the chord because it got bisected, and so the other half of the chord, DF, is 10, so BF would have to be 10. Okay. BD is that whole chord that got bisected from B to D. Both halves are 10, so the total is 20. Okay. Arc BD, well, according to the theorem, the arc gets split in half also. It gets bisected. So if the AB is 33, AD also has to be 33. And so the whole arc, BD, would have to be 66, those two added together. Well, if they also want us to find the major arc, BGD, which is basically the rest of the circle, you would take that 66 degrees, the BD, and subtract that from the full circle. So 360 minus 66 would give us 294 for the major arc BGD. Okay, so all those pieces basically get cut in half. All right. Okay, another example, just kind of doing the same thing but algebraically. And so it looks like BD is a diameter, and it's also perpendicular to that chord. Therefore, the second theorem says that it has to bisect the chord and it has to bisect the arc. All right? So they're asking us for arc CD. Well, arc CD is 9x. Arc DE, it has to be congruent to, is 80 minus x. And so we would set those two equal to each other. And so if you set those equal to each other and add x to both sides, you would get 10x equals 80. And so x would have to be 8. And so if we plug in for what CD is 9x, so 9 times 8 would give us 72 for the arc CD. All right. CE is both of those arcs put together, and so you would just double 72. So 72 and 72 is 144, so that's the measure of arc CE. Then they want us to find the measure of major arc CBE. So again, that's the rest of the circle. If minor arc CE is 144, then major arc CBE is 360 minus 144, and so that's 216. Okay, so hopefully those make sense based on those two theorems. Okay, our last slide here, this has another theorem on it. It says that two chords are congruent if and only if they are equidistant from the center. Now, equidistant, remember, means equal distance, okay? And you have to go back a little bit to our definition of distance. How far is a line or a segment away from a point? Remember, the shortest distance is that distance, and that shortest distance is perpendicular. So we're always talking about a perpendicular distance from the center out to a chord. And so notice in this diagram, chord QR and chord ST are both 16, so they are congruent. That means they have to be equidistant from the center. That means that UC and VC have to be congruent. Those two distances have to be the same. Okay? And it would be the other way around, because it's an if and only if. If you knew that UC and CV were congruent to each other, then the two chords would have to be congruent to each other as well. So this question is asking us to find X and then to find CV. Well, again, the X is representing the UC and X is also in VC. We know those are congruent to each other because the two chords are congruent to each other. So let's set up that equation. 2x would have to equal 5x minus 9. Those two distances would have to be equal to each other. So if we pull subtract 2x from both sides, we would get 3x on one side, move the 9 to the other side, or add 9 to both sides, we get 3x equals 9. Divide by 3, we would get x is equal to 3. So they want to know how far the distance CV is. So we would take that 3 and plug it into either one of them because they're the same. You could just go 2 times 3 or 5 times 3 minus 9. Either way, you're going to get 6 for that distance. Okay? So several theorems in here. I know we're moving quick here, but several theorems in here that you need to catch and make sure that you understand how those work. So you may need to rewind this and check on some of those again and make sure that you understand those. All right, and we'll look at some examples in class. So we'll see you guys there.